It was a respected second when the Andromeda Cloud, for the present, changed into the Andromeda Boundless System. The James Webb Telescope has seen 6 universes that existed a piece of a billion years after the colossal impact. This is extraordinary when you truly take a gander at the night sky. A pinpoint of light, when widened, gives you one of these photos from the Webb Space Telescope. It was a regarded moment as the Andromeda Cloud transformed into the Andromeda Galaxy. For quite a while, our awareness of the Andromeda Galaxy was restricted to basic observations. However, with advancements in technology and the introduction of the James Webb Space Telescope, our knowledge has expanded massively. Now, things are about to change, as the James Webb Space Telescope has detected disturbing signals coming from the Andromeda Galaxy. These signals have sent shockwaves through the scientific community, leaving astronomers both excited and curious. But what exactly do these signals mean? And why are they creating such an upheaval among space experts? Just 2 minutes earlier, the James Webb Telescope shut down after detecting disturbing signals from the Andromeda Galaxy. Previously, we could see far beyond our eyes into the universe. Astronomers once believed the Milky Way was the entire universe. This lack of knowledge was primarily due to limited technology for observing other galaxies and individual stars. However, everything changed when we discovered the Andromeda Galaxy. It served as the first major indication that the universe extends far beyond the Milky Way. In the 17th century, Galileo Galilei's pioneering work with telescopes revealed the nature of the Milky Way. He observed that it contained numerous stars, challenging the prevailing belief in its singular importance. Everything changed in the 1920s when Edwin Hubble observed distant objects beyond the Milky Way using the Hubble telescope. He discovered that these bright objects moving through the universe were, in fact, galaxies, distinct from the Milky Way. One of these galaxies was the Andromeda Galaxy, or M31. While this was the first time Andromeda was observed through a telescope, Persian astronomer Abd al-Rahman al-Sufi had recorded it as early as the 10th century. Thanks to technological advancements in the 20th century, astronomers could finally study and understand the true nature of Andromeda. It is a vast galaxy much like our Milky Way. Our cosmic neighbor is approximately 2.5 million light-years away from the Milky Way. Since its discovery, our understanding of Andromeda has evolved significantly. We have progressed from ground-based telescopic observations to space observatories like the Hubble and the James Webb Space Telescope. Each technological breakthrough has allowed us to reach new heights, uncovering the mysteries of the Andromeda Galaxy. We now have more information about its composition and structure, making Andromeda a key reference for studying galaxy evolution. This has provided deeper insights into the fundamental workings of the universe. Scientists believe that to better understand our universe and the Milky Way, we must focus on the relationship between Andromeda and the Milky Way. This is particularly important because the two galaxies are destined to collide in approximately 4 billion years. While studies and predictions have advanced, the James Webb Telescope has recently detected a disturbing signal from Andromeda. This signal has puzzled scientists, raising questions about its origin and potential implications. The James Webb Telescope's advanced sensors have detected unusual activity within Andromeda. The signal sent back to researchers shows results that are entirely different from past observations, astonishing scientists worldwide. The signal suggests massive processes occurring within the galaxy, possibly linked to its supermassive black hole or previously undiscovered events. Notably, one of the latest discoveries indicates that Andromeda's mass may be significantly greater than that of the Milky Way, reshaping our understanding of both galaxies. The James Webb Telescope has also provided detailed images and spectra of Andromeda, revealing the formation of new stars and their chemical compositions. This new data is crucial for understanding cosmic evolution and the conditions for life. Additionally, findings from the telescope suggest increased activity in Andromeda's dynamic galactic core. This, in turn, has impacted its surrounding environment and is expected to shape its future development. By analyzing the gravitational effects on stars within Andromeda, experts gain insights into the distribution of mysterious dark matter throughout the galaxy. Understanding dark matter and its influence on the universe remains one of astronomy's greatest challenges. Recent breakthroughs from the James Webb Telescope have sparked numerous studies as researchers explore Andromeda's secrets in greater detail. With more data becoming available, we now have a better understanding of its past and future. So, what have we learned about the Andromeda Galaxy? Various studies have shown that Andromeda possesses unique characteristics that set it apart from other galaxies. Its immense size commands attention, with recent estimates suggesting it spans approximately 220,000 light-years. This makes it one of the largest galaxies in the local group, even more massive than the Milky Way. This vast size contributes to its estimated trillion stars, surpassing our own galaxy in star count. Research also reveals Andromeda's fascinating structure. Unlike a typical spiral galaxy, Andromeda has an expanding core and a dense center, encased within rings of dust and gas. This makes it a rich environment for continuous star formation. One particularly intriguing feature is its core, which exhibits a double-peak emission pattern, indicating the presence of a supermassive black hole. Though similar to the Milky Way's black hole, it has distinct characteristics that provide valuable insights into the nature and behavior of these cosmic giants. The Andromeda Galaxy is also surrounded by a vast halo of stellar debris, including stars, planetary systems, and globular clusters stretching hundreds of thousands of light-years in diameter. This immense halo tells a fascinating story of the galaxy's origins and evolution. Andromeda contains approximately 460 globular clusters, offering critical information about star formation in its earliest stages. These clusters help scientists better understand the formation of star groups and the early development of the universe. By unraveling the mysteries of Andromeda, astronomers take one step closer to understanding the larger workings of our universe. To understand the enormous pertinence of dark matter, one must consider how scientists address its baffling nature and the role it plays in the structure of immense systems. Andromeda boasts another significant component: its satellite galaxies. Its crown structure consists of more than 20 smaller galaxies, some of which are undergoing tidal stripping, losing their stars and gas. This process involves a larger galaxy pulling in and disrupting smaller cosmic structures, showcasing the dynamic nature of galactic evolution and how galaxies interact over extended periods. So, what does the future hold for the Andromeda Galaxy? The shape and trajectory of its evolution intrigue not only cosmologists but also those striving to understand the universe. The possibility of Andromeda transitioning from a spiral to a ring galaxy is a fundamental consideration. Observations suggest that this transformation may be influenced by previous interactions with other galaxies. If Andromeda is indeed moving in this direction, it implies that it has undergone multiple encounters since its formation. Ultimately, Andromeda's fate is tied to its inevitable collision with the Milky Way. According to models, this impact is estimated to occur approximately 4 billion years from now. The result of such a collision will be the formation of a new galaxy from these two massive celestial bodies. While this event is part of cosmic evolution, the vast distances between individual stars mean that direct stellar collisions will be rare. Instead, the gravitational effects will reshape both galaxies, forming new structures and triggering intense star formation as their gases and dust interact. This cosmic merger will create a spectacular display, with newly ignited stars shining brightly. At the heart of this event lies another fascinating phenomenon: the merging of the supermassive black holes at the centers of both galaxies. This collision is expected to generate immense gravitational waves and unleash high-energy radiation, offering invaluable insights into the nature of black holes and galactic evolution. A crucial question remains: what will happen to our solar system? While total destruction is unlikely, the gravitational disturbances could alter the Sun's position within the newly formed galaxy. This might result in changes to Earth's orbit, possibly affecting its climate. A shift farther from the Sun could trigger a new ice age, while a closer proximity might lead to significant warming and rising sea levels. Moreover, variations in cosmic radiation levels could further impact planetary conditions. The Milky Way and Andromeda are destined for a colossal collision, an event that will reshape the cosmic landscape. This impact, estimated to occur in about 4 billion years, will be one of the most significant in the history of the universe. As the two galaxies draw closer, their mutual gravitational attraction will initiate a dramatic dance of immense forces. This merger is not a sudden impact but rather a gradual integration process. During this phase, interactions between the galaxies will trigger an extraordinary burst of star formation. The gravitational turbulence will compress interstellar gas and dust, sparking new stellar births. This starburst phase will create a breathtaking display, with newly formed stars illuminating the merging galaxies. As the Milky Way and Andromeda continue their inevitable path toward collision, there is much to consider regarding the outcome of this monumental event. This galactic merger is more than just a blending of stars, gas, and dust. It will have profound implications for the formation of new cosmic structures. The impact will create an environment where star formation rates surge, driving an unprecedented wave of activity. The gravitational forces at play will pull matter together, resulting in a celestial rebirth accompanied by bursts of radiation from newly ignited stars. Beyond the visual spectacle, this event will also significantly impact interstellar dynamics. The gas clouds and dust particles that fill the space between stars will be compressed, forming new star systems and altering the structure of the resulting galaxy. The chaotic forces at work may even reveal hidden aspects of dark matter, offering new insights into its role in shaping galaxies. As the Milky Way and Andromeda collide, their supermassive black holes will inevitably move closer together, ultimately merging into an even larger black hole. These behemoths, each millions or even billions of times the mass of our Sun, will unleash powerful gravitational waves. Such an event would provide scientists with a rare opportunity to study these phenomena in greater detail. The energy released will be immense, producing a burst of radiation that could affect surrounding regions and perhaps even the broader universe. Despite the immense forces at play, the likelihood of individual stars colliding remains low due to the vast distances between them. However, the gravitational disruptions could dramatically alter planetary systems, potentially ejecting planets from their orbits or pushing them toward their parent stars. These gravitational shifts may significantly impact the conditions for life on any affected planets, making survival in such an environment uncertain. As the new galaxy emerges from the merger, its structure may differ greatly from the original spirals of the Milky Way and Andromeda. The resulting galaxy could take on an elliptical or irregular shape, far removed from the familiar spiral arms we see today. Its stellar population will be a mix of stars from both galaxies, each with varying ages and chemical compositions. The newly formed galaxy may be much larger and more complex than either of its predecessors, offering an entirely new cosmic landscape for future generations to explore. In the grand scheme of things, the Milky Way-Andromeda collision represents just one chapter in the long and turbulent history of the universe. Galaxies are in constant motion, drawn together by gravity only to eventually merge and evolve. This process of cosmic evolution is ongoing across the universe, and our galaxy's fate is governed by the same fundamental principles that dictate the birth and death of stars, the formation of black holes, and the expansion of space itself. For humanity, the merger of the Milky Way and Andromeda may seem like an event too distant to worry about. However, understanding this cosmic process is crucial for expanding our knowledge of the universe. By studying such galactic collisions, scientists gain insight into the forces that shape not only individual galaxies but also the larger structure of the cosmos. As we continue to observe and explore the mysteries of the universe, events like the Milky Way-Andromeda merger bring us closer to comprehending our place in the cosmos. Ultimately, this collision is a reminder of the perpetual change that defines the universe. While it may take billions of years for the galaxies to merge, the knowledge gained from this astronomical event will continue to inform our understanding of the universe long after the collision has taken place.